This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is our second example, finding the arc length of a circle. So we're going to do this problem. Find the length of the arc intercepted by the central angle 135 degrees in a circle of radius 32 inches. And then we want to round our answer to the nearest tenth of a foot. So remember, we found out the formula for arc length could be thought of as S equals R theta, where R is in radians. R is the radius and theta is in radians, right? And it comes from the definition of the radian measure. So we're going to use this formula, S equals R theta. So we need to know R and theta. All right, R is the radius, and that's given right here as 32 inches. And theta, is the angle. Now we got to be careful here. The angle must be given in radians, but I gave it to you as 135. Let me make that green. Sorry. 135 degrees. We cannot put that in the formula when it's in degrees. So our first step is to change 135 degrees to radians. So how do we do that? I want to get rid of the degrees. So I could multiply this by, well, I need to get rid of the degrees, so I want 180 degrees in the denominator, and that's the same thing as pi, because pi is actually equal to 180 degrees. And now we're going to have to simplify this. And so I'll let you do that on your own, but 45 goes into both of those numbers, and the degrees cancel, and you end up with 3 pi over 4. Okay, now if you're having trouble reducing fractions, you might want to practice that. But you could start by just dividing both numbers by 5, for instance. So if you, in other words, how do you reduce? You could divide the top and bottom by 5, and that'll give you 27 over 36. And then you could divide the top and bottom by 9, and you get 3/4. So that's where I got that 3 pi over 4. That's one way you might be able to do it. That's basic arithmetic. But I did get rid of the degrees, and I do now have theta in radians, and so now I can use this formula. Okay? So the formula says it's going to be the radius, 32 inches, and I'm going to write that as just 32, leave off the inches, times 3 pi over 4, times 3 pi over 4, and my answer will be in inches because that goes with that 32. And let's see, does anything cancel? The 4 goes into 32 8 times. So I get 8 times 3, 24 pi inches. Now, that's the exact answer. But the problem said round to the nearest tenth of a foot. That way you get a more feel for what this stands for. So 24 pi inches is approximately what? You just want to get out your calculator, do 24 pi. So you put in 24 pi, and then you're going to round it to the nearest tenth, and that comes out to 75.4 inches. Right, so that looks like it's the answer we're looking for. Now, let's get a picture of this to see if that seems reasonable. So in our original problem, we had a central angle of 135 degrees, and the radius was 32 inches. So let's see, let's draw a picture of that. All right, so here was our problem. We came up with the arc being approximately 75.4 inches. So let's see if that makes sense if we drew a picture. So here is a radius of 32 inches, right? And then we've got 135 degrees. Now, where is that? Well, it's 90 to here, it's 45 more, so we're talking about 45 degrees out here. And what we're looking at is this length right here. And so the question is, does that look like it's close to 75.4 inches? I'd say, well, if this is 32 inches, I'd say maybe that's 32, 64. Yeah, it looks like it's in the ballpark. So you don't have to do this, but it's helpful. Let's say you're taking a test, at least, to kind of see, does it look like it's like, at least close to what you would expect the answer to be. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.